another trig equation for us to solve, and this one looks a little bit trickier. I see two different trig functions. I see sine and cosine, and they're not connected by multiplication. They're connected by subtraction here, so I know that I'm not going to be able to factor them into separate factors. I'd be okay with that, but because they're connected by subtraction, that's not going to work. I also see two separate angles here. I see x and 2x, and again, they're connected by subtraction, so I'm not going to be able to split those up into separate factors. Okay. So when that's the case, when I have two different trig functions or two different angles, and I can't separate them into distinct factors, I'm going to need to use some trig identities. So I'm thinking we want a double angle formula for cosine because it's easier to simplify that. I've got a formula for that. So let's write down what that is. I've got cosine of 2x. That would be cosine squared x minus sine squared x. That's the version that falls out directly from the sum formula. Now, I like this piece because then that would just be some more sine x's. Not so crazy about this piece. At least we've got the same angle now, but we still have a different trig function. But remember, I've got my Pythagorean identity that gives me another version of the double angle formula for cosine. I can replace cosine squared with 1 minus sine squared. Then I've still got this 1 minus sine squared. I can say it's 1 minus 2 sine squared x. Now if I do that, if I replace cosine of 2x with this, then the only trig function I have is sine, and the only angle I have is x. I'm liking that. So we will have 1 minus 2 sine squared x, that's my cosine 2x, minus 3 sine x, minus 2 equals 0. Now, it's set equal to 0 here, but I want to do a couple of things. First of all, I want to go ahead and consolidate those constant terms. So I've got negative 2 sine squared x, minus 3 sine x, minus 1 equals 0. Okay. I could try to factor it here, but it's a lot easier to factor if the squared term is positive. So what I'm going to do is now multiply through by a negative 1. Or equivalently, I could just move everything over to the other side. Okay. I'm going to think of it as multiplying through by a negative 1. All that's going to do is change every single sign. So it becomes positive 2 sine squared x plus 3 sine x plus 1 equals, and the right-hand side, of course, is still 0. So now I've got something that's quadratic in form. It's quadratic in sine x. So I'm hoping that I can factor this. I'm thinking of that as being the result of foiling. And if my first terms are going to give me 2 sine x, I'm thinking we'll have a 2 sine squared x. I'm thinking the way we'll get that is 2 sine x and sine x. Now, the numbers that go here have to multiply to give me 1, so I'm thinking 1 and 1. And they've got to have the same sign so that they multiply to give me positive 1. And since everything is now positive, I'm thinking both positive. So let's just try that, see if it works. Then the outsides would be 2 sine x, the insides would be sine x. They'd combine to give me 3 sine x. Okay, excellent. So we were able to factor this one. So now I can set each factor equal to 0 and solve those. So here I would have 2 sine x plus 1 equals 0, or sine x plus 1 equals 0. All right, those are the two now linear in form equations that I'm solving. I would isolate the sign, so sine x would equal negative 1/2. That's a negative number. Sine is negative in quadrants 3 and 4. So I'm going to have two solutions, one in quadrant 3, one in quadrant 4. Both of them will have the same reference angle, and I know that sine of alpha will just be the absolute value of negative 1/2, which is positive 1/2. Now that's one of my nice values, So if I look at my 30, 60, 90, or again, I might not need to look at this, I might just know it, I'm going to see that's my 30-degree angle, or pi over 6. So here, we had that x was pi plus alpha. That's going to become pi, which is 6 pi over 6, plus pi over 6. So that's going to give me 7 pi over 6. Here, I can see x was 2 pi minus alpha. 2 pi would be the same as 12 pi over 6 minus pi over 6. So that's going to give me 11 pi over 6. Excellent. So I'm going to put, whoops, oh my, I still have up the answer to the last problem. That was completely irrelevant to this problem. I should have erased that first. Sorry about that. Okay, so I'm going to list those as two of my solutions, 7 pi over 6 and 11 pi over 6. Those are two of my solutions in this interval, but that was just dealing with this factor. Now I've got to deal with this other factor. So that would mean sine of x equals -1. Now that's a special value. That's the lowest we can have. So I'm thinking there we got to look quadrantal angles. Sine is the capital Y value. So the terminal ray of my angle has to pass through the negative y-axis. The only angle in the interval from 0 to 2 pi that does that would be 3 pi over 2. So this, setting the first factor equal to 0, gave me two solutions between 0 and 2 pi. This one only gave me one. That's okay. I've got three solutions between 0 and 2 pi. And then I can find all solutions by simply adding a multiple of the period. And the period, of course, is 2 pi. So 7 pi over 6 plus 2 pi n, 11 pi over 6 plus 2 pi n, 3 pi over 2 plus 2 pi n, where n is an integer.